Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to look at question 6 of the assignment I gave my learners for mathematics grade 10, and that assignment was on number patterns. This paper comes from the 2016 November paper of the Department of Education, and this one was published by the Gauteng government. All right, let's start from the beginning. Question 3. Dark tiles D and light tiles L are used to create patterns on the floor. The first four patterns are shown below. For the patterns that follow, the tiles are arranged in a similar manner. Okay, this is what we have. In pattern 1, we only have a gray one, dark. Pattern 2, 3 gray, 1 light, and so on and so forth. How many dark tiles were used in pattern 5? Okay, we've got 1 in pattern 1, right? Dark tiles. All right, so dark tiles, 1 in pattern 1, and then we've got 3 in pattern 2, D3. Okay, we're just gonna call it D, so you can see we've got 3 in pattern 2, and then we've got how many in pattern 3? 5. And then in pattern 4, we've got 4, 7. Okay, dark tiles. Okay, there's 7. Okay, there's a pattern, so it's 1, 3, 5, 7. How many dark tiles were used in pattern 5? So here is the dark tiles 3.1. They form a pattern. The dark tiles form a pattern. Let me just check. Okay, so 3.1. The dark tiles form a pattern, and the pattern is 1, 3, 5, 7. 1, 3, 5, 7. Let's go back and double check. Yes, 1, 3, 5, 7. And this, let's check if this is a linear pattern. All right, the difference between 3 and 1 is 2. Same over here. 5 minus 3 is 2. 7 minus 5 is also 2. So they form a linear pattern. All right, they form a linear pattern, and that pattern has got a constant difference of 2. Okay, the first term is 1, obviously. All right, now to find the pattern in, okay, to find the number of dark tiles used in pattern 5, that should be, all right, easy. In pattern 5, the dark tiles used will be 7 plus the distance. Okay, so term 5, that will be term 4 plus the constant difference, and that is equal to 7 plus 2, and that gives us 9. So 9 dark tiles were used in term pattern 5. And let's fix this. All right, next, 3.2. How many light tiles were used in pattern 6? Okay, here are the light tiles. Pattern 1, 0. Pattern 2, 1. Pattern 3, 4. And so on and so forth. Okay, let's label them. Okay, light 0. Light 1. Okay, light 4. And then light how many? 3, 6, 9. Light 9. All right, here is the pattern for the light tiles. All right, that's 0, 1, 4, 9. 0, 1, 4, 9. Okay, 3.2. Sorry, 3.2. That's 0, 1, 4, 9. That is how it looks so far. So that is 1, 2, 3, 4. Okay, so now they want to find out what the number of tiles, light tiles in pattern 6 was going to be. So we're looking for term 6. Now notice, these look like squares. 1 is 1 squared, 4 is 4 squared, 2 squared, 9 is 3 squared. But notice here, instead of, for term 1, instead of 1, we have 0. How did that happen? So that looks like it was going to be 1 minus 1 all squared, and that will give us 0 all squared, which is 0. All right, 2 minus 1, and the next one, 2 minus 1 all squared will be 1 all squared, which is 1. And then 3 minus 1 all squared in the next one will be 2 all squared, which is 4. So we've got a pattern here. All right, so term number 6, pattern number 6 will be 6 minus 1 all squared. 6 minus 1 all squared, which gives us 5 all squared, which is equals to 25. And the question was, how many light tiles were used in pattern 6? All right, therefore, 25 tiles were used in pattern 6. Therefore, 25 tiles, 25 light tiles were used in pattern 6. Were used in pattern 6. All right, next question, 3.3. Write down the general term, dn, of the number of dark floor tiles used in each pattern. So we're looking for the general term of the dark tiles. So 3.3, we're looking for the general term. Okay, this one was a linear pattern with a equals to 1 and d equals to 2. All right, okay, that was a linear pattern, and that has got a general term of a plus in bracket n minus 1, n minus 1 all times d. All right, we know that a equals to 1 for this one and d equals to 2. With a equals to 1 and d equals to 2, let's substitute that. Therefore, dn equals to 1 plus in bracket n minus 1 times 2, which is equals to 1 plus 2n minus 2, and that gives us 2n minus 1. Therefore, the general pattern of the dark tiles is 2n minus 1. Let's go back to 3.4. 3.4 says, write down the general term ln of the for the number of light floor tiles in each pattern. That should be easy as well. So 3.4, 3.4, okay, ln will be, okay, in bracket n minus 1 all squared. This one is very easy. Okay, 3.5, which pattern will have exactly 64 light tiles? Okay, so we're looking for light tiles equals to 64. 3.5, what is n? If that is equals to 64, what is n? All right, therefore, okay, n minus 1 all squared equals to 64. All right, okay, if you found the square root, that will be, okay, therefore let's find the square root of both sides. Therefore, if we, the square root of n minus 1 all squared will be n minus 1 equals to the square root of 64. Therefore, n minus 1 equals to 8. Therefore, n equals to 8 plus 1, meaning that n equals to 9. And the question, okay, sorry. Therefore, the ninth pattern will have, therefore, the ninth pattern will have 64 tiles. Will have 64 light tiles. 64 light tiles. All right, let's go to the last question, I believe. 3.6. Each duct tile is 0.3 meters wide and 0.6 meters long. Calculate the total area covered by all the duct tiles in the first 100 patterns. So we need to figure out how many those are. All right, remember the duct tiles have a pattern that is a linear pattern. All right. So, okay, each tile, all right. So let's figure out how many in total the duct tiles, all right, for the area covering 100 patterns. All right, so looking for D100 first. Okay, each tile has got the length of 0.6 meters and a width of 0.3. Okay, so this is 3.6. Total area of duct tiles. That's what we're looking for. And each tile has got the area of 0.6 meters times 0.3 meters. All right, let's figure out how many tiles cover 100 patterns. An area covered by 100 patterns. Okay, the duct tiles, yes, the duct tiles are. Number covering 100 patterns. Remember, it's 100 patterns, not, okay. All right, so we're going to look for the sum of the first 100 times. Remember, the first sum of this is a linear pattern, so the sum of the first n terms will be n over 2 in bracket 2a plus, of course we're cheating here, I'm showing you what you're going to be learning next year and in grade 12. So, but why not learn now? So we're looking for the sum of the first 100 patterns. The sum of the first 100 patterns will be 100 over 2 times, okay. What is the first term? The first term is 1, so that is 2 times 1. Plus 100 minus 1, that is 99, times d. D is 2, I believe. Yes, there are some differences too. And that gives us an answer of, let's see how many tiles in total we have. That is common fraction button, 100. Downward arrow 2. Right arrow, open bracket, 2 times 1 plus 99 times 2, close bracket, equals to, and that gives us 10,000. So that is covered by a total of 10,000 tiles. All right. So the area, the total area will be equals to 10,000 tiles multiplied by the area of one tile, which is 0.6 times 0.3. And that gives us, okay, 10,000 open bracket 0.6 times 0.3 close bracket, and that gives us an answer of 1,800 square meters. That is the total area covered by the duct tiles. All right, and the first 100 patterns. And that is the last of the questions and the end of the videos from the assignment. Thank you so much for watching. I'll see you in the next series. Bye bye.